All right, new pattern, day 93. We're doing topological sort. The pattern is real world applications and some problems we can solve with it. So the pattern examples doesn't match this pattern, it's etc. etc. So it's a technique used to organize a collection of items or tasks based on their dependencies. Okay, imagine there's a list of tasks to complete, but some tasks can only be done after others are finished. There are many such tasks that depend on each other, or there is a specific sequence of actions that must be followed. For example, when baking a cake, there are several steps one needs to follow, and some steps depend on others. Okay, like when cooking something. We can't frost the cake till it's baked, and we can't bake it until we've mixed the batter. So to ensure that we don't frost the cake before baking it or mix the batter before after preheating the oven, we need to sort the steps based on their dependencies. And this is where TopoSort helps us. It figures out the correct sequence of steps to bake the cake efficiently. It's used to find valid orderings of elements that have dependencies on or priority over each other. And these elements can be represented as nodes of a graph. So in technical terms, toposort is a way of ordering nodes of a directed graph such that for every directed edge AB from node A to B, A comes before B in the ordering. Now, it's only applicable to directed acyclic graphs, DAGs, meaning there should be no cycles present in the graph. And if we write a recipe for baking a cake, then the list of tasks goes like first mix the batter, then bake the cake, then finally frost it. So these tasks can also be organized into a graph where each task is a node and the dependencies between tasks are represented by directed edges. So we have this sweet diagram here. So order of tasks. So in an array, we mix the batter, bake the cake, frost the cake, and graph rep in toposort. A is performed before B is performed before C, etc. A is mix the batter, B is bake the cake, C is frost the cake. However, if we mistakenly add an additional step to our recipe that contradicts any of the existing steps, it introduces a cycle in our graph. For example, if the recipe goes like mix the batter, frost the cake, bake the cake, frost the cake, we can't frost a cake that hasn't been baked and can't bake a cake that's already frosted. Similarly, in a graph with cycles, we can't establish a clear order of tasks, making topo sort impossible. Therefore, topo sort is only applicable to directed acyclic graphs, which we've mentioned before, where tasks are organized into a logical sequence without any contradictions or cycles. So cycles bad. So it's crucial for converting a partial ordering into a complete ordering, especially when certain tasks have defined dependencies while others do not. For example, we have a research project with 5 tasks, A, B, C, D, E. Some tasks depend on others. So A must be completed before B and C, and task B must be finished before task D. Tasks before D and C must be done, okay? So A must be finished before B and C, B must be finished before D and C. Can be done. Before D, actually. This combos is so confusing. And C must be done before E. Okay. However, when it comes to performing tasks B and C, it's unclear which one should be first. Okay. This is where TopoSort comes in. It helps us convert this partial ordering into a complete ordering, providing clarity on the sequence of tasks to ensure efficient execution. There can be multiple possible valid orderings of the elements. For example, based on the given dependencies in our example, some valid orderings could be these, and they're all valid. And now this is a visual demonstration. So it can be this way, right? Okay, okay, okay. All right. This is just one, right? B could have been before C without issue, but yeah. Worth noting, and here are some examples. So all right, here are some examples. You can solve course prerequisites. Oh, if you're in a school, I mean, most people watching this, you can relate. So we have a list of courses with prerequisites. Is it possible to complete all of them? And if so, provide a valid order. And we have this diagram here. Okay, these are the prerequisites for these, and these are different ways we can get them done. And then minimum height of a tree. Given an input tree, we can redraw it with different nodes at the root. Of all the trees, we want to find the root node of the tree with the minimal height. So return multiple nodes of multiple trees with different root nodes have the same minimum height. Lots of words there, but here n for number of nodes. These are the connections. So keeping track of the minimum height, associated root, the minimum height has a height of 2, formed by selecting 1 and 2 as a root. Okay, sure. Seems like a lot of words, but how do you know it matches? If there's a dependency relationship, and if ordering or sequencing problems are involved, or prerequisites, etc. And then it doesn't work if there are cycles and if the dependencies are dynamic. There are real world examples: recipe planning, course scheduling, process scheduling in a computer, and then strategy time. We have words in a dictionary. I'm just kind of cheating, but I know that already works. And then connected components in a DAG. Let's say this uniquely constructed from subsequences. I'm gonna say this. I'm gonna say this. Did I get it? Oh, I got one wrong. I got two wrong actually. Okay. So reset. Yep. So this is supposed to go here. This is supposed to go here. This is supposed to go here. Actually, no. This, yeah. And this is supposed to go here. Or I'm gonna show the solution. Okay. So this is here. And then there are a bunch of explanations that I don't know if I'm interested in, to be honest. It's a lot of gobbledygook, lots of words. Doesn't really help you solve the problem at the end of the day, but this is the next thing we're going to look at on compilation order. I've gone through some of these. This one was particularly hard, but should be exciting. I read them, right? But then I'm going to step through them with the debugger, fully understand them, and make videos about them. So stay tuned. Ciao.